So welcome students. In this question you're given that f of x is x mod x and g of x is sin x. And you're asked to find the nature of GOF of x at x is equal to 0. The first statement says GOF is differentiable at x is equal to 0 and its derivative is also continuous at x is equal to 0. Second statement is GOF is twice differentiable at x is equal to 0. So let us analyze the nature of GOF. So you know what GOF is. GOF of x is nothing but g of f of x, right? That is equal to g of, that is sine of f of x is x mod x, right? So what is the nature of sine of x mod x? Obviously mod x is a piecewise defined function. So this is equal to sine of x square if x is greater than or equal to 0, right? Because when x is greater than or equal to 0, mod x is equal to x. And sine of minus x square if x is less than 0. Sine of minus x square if x is less than 0. That is, minus can be taken out from sine. Minus sine x square if x is less than 0. So if x is greater than or equal to 0, it is sine of x square. If x is less than 0, it is minus sine x square. This is my GOF of x. Now, you have to check whether GOF is differentiable at x is equal to 0. So first, let us try to differentiate this. So this is a piecewise defined function, and function wise these are nice functions. So you just need to check the left limit of the differentiation and the right limit of the differentiation at x is equal to 0. If both are equal, then it is differentiable. So GOF dash of x is equal to, so when x is greater than or equal to 0, that is cos x square times 2x. When x is greater than or equal to 0. And when x is less than 0, we have minus of cos x square times 2x. So this is GOF differentiation. Now let us see whether this is differentiable at x is equal to 0. So if this has to be differentiable at x is equal to 0, that means this differentiation should have the same limit when x is greater than 0 or when x is less than 0. So what is the left limit GOF dash at 0? So where does GOF whole dash go when x is going to the left limit, that is x tends to 0 minus, is nothing but, so put x is equal to 0, so you get 0 here. Similarly, right limit of GOF dash of 0 is again nothing but, if you put x is equal to 0 here, you're getting 0. That means the right limit of the differentiation at x is equal to 0 is same as the left differentiation at x is equal to 0. Hence, GOF is differentiable at x is equal to 0, right? And the derivative is continuous at x is equal to 0. Yes, because the right differentiation is same as left differentiation is same as the functional value. Exactly at x is equal to 0, the differentiation is also equal to 0. So GOF is continuous and differentiable at x is equal to 0. There's no doubt about it. Now, the next question is GOF twice differentiable? So let us try to see the next differentiation. What is GOF double dash of x? So you just need to differentiate this again. This is a cos x square into 2x. This is a product function. So you need to use UV method. So 2x times minus sine x square times 2x. 2x times minus sine x square times 2x plus cos x square times 2 when x is greater than or equal to 0. And minus 2x times minus sine x square times 2x minus of, you can take minus as common, so 2x times minus sine x square into 2x plus cos x square times 2 when x is less than 0. So now what is GOF double dash of x at 0 plus and 0 minus? So what is GOF double dash at 0 plus? Where does it tend? So if you put 0 plus, that is the right side function, and if you put 0 in this, you're getting, so this becomes 0, this becomes 2 into 1 is 2. The right side double differentiation is 2. And what is the value of double differentiation of GOF at 0 minus? That is, just need to put x is equal to 0 in this function. So you have minus of, this becomes 0 and this becomes 2 is equal to minus 2. So the right side double differentiation value is plus 2. The left side double differentiation value is minus 2. So both are not equal. That means GOF is not twice differentiable at x is equal to 0. So the first statement is true. The second statement is not true.